What we've got is manganese dioxide, manganese 4 oxide, okay? It's called manganese 4 because that's oxidation status plus 4, yep. Okay, and I'm going to put into that some concentrated hydrochloric acid. Okay, and you'll see some, hopefully some reaction going on there. Well, if it's going outside the tissue, it's going against gravity, isn't it? Surely it couldn't do that. Okay, this is called starch iodide paper. I'll explain how it works later, but it's going up tissue, isn't it? That's fantastic. I'm trying to lower the starch iodide paper in there. It's not meant to go against gravity. As you can see now, we have starch iodide paper has gone from white to a dark blue-black colour. Okay, there's a bit of a clue there as to what one. So what has happened in the starch iodide? Starch iodide paper is really technical. You take paper and you soak it in starch and potassium iodide solutions. Okay, which isn't very technical at all. I was just having you on, but anyway. Now, what happens is the reaction in here is producing a green colour. I think you can see a bit of a, well, apart from the anti-gravity matter in there. Okay, there's a green colour in the background that you can see. That's the chlorine gas. The chlorine gas reacts with the iodide ions, another redox reaction, to make iodine and chloride. It's the iodine with the starch. Okay. Anti-gravity, antimatter. Well, if you believe that, you believe anything. One of my third forms believes that switch over there turns gravity off. Seriously, it does. 3C. There you go. 3C. Huh? No, but then someone turned it off and it didn't switch gravity off. He was very disappointed. Okay, the next one. Take that one out. Yep. Is copper and concentrated nitric acid. You know what happens here. You've seen it before, so it's always good to watch. It's fun to do. Because our general perception of copper is it's not reactive with acids, okay? But when you take concentrated nitric acid, alright, which is lovely stuff, we get a fairly rapid reaction, as you can see in there, okay? Already we've got green colour forming, okay, and if I just back off a little, we can see the right, the significant amounts of brown gas, which is nitrogen dioxide being formed there. Okay, the green colour in the bottom is indicative of which ion? Copper. Which copper ion? Cu2 plus, yep, okay. Now I'll just let that run its course and then I'm going to show you the difference between copper ions in a very concentrated form there, which is a green colour, and in a diluted form by adding some water to it. Okay, so we can see hydrated copper ions. That's not a redox process, it's just a hydration one. So when I do this, we get that colour change to blue, okay, which we hone back in. Okay, so those are the hydrated copper ions. Right. H2O. No, water, not that American stuff. No. Okay, and reaction J on your list has got lead 4 oxide, PbO2. So this is the stuff that's in car batteries. So it's what coats the plates in car batteries. It probably looks to you like it's black, but it's a very dark mauve colour. I think it looks mauve. It's not purple. More of a reddish purple, but it's not actually black. Anyway. So once again, we're going to add to that concentrated hydrochloric acid. Okay, a bit of anti-gravity going on here again. Similar type of reaction to the first one, but more vigorous, right? Okay, so we would anticipate therefore a quicker result to our starch iodide test, and very quickly we've got the black colour produced. Okay, notice the colour change. Okay, the product, which is in fact lead 2+ ions. Okay, and that's gone yellow. Okay, so it's lead 2 ion, which is yellow. Okay, and it's not reacting because it has finished. It's used pretty much all of the lead 4 oxide up. I can tell that because there's no dark colour left. Does that make sense? Okay, so just to recap the redox process, so you can write the equations while I'm tidying that up. In both of the manganese dioxide and lead dioxide ones, the process is the same. The metal ion is 4+ oxidation state, and it goes to 2+. But you can't just write Mn4+, it's not Mn4+, it's MnO2. So your half equation's got to have MnO2 in it. Okay, it's going to have Mn2+, and it's probably going to have some hydrogen ions and some concentrated acid. So but the MnO2 one and the PbO2 one is similar. As far as the copper and nitric acid one goes, you've done it before, you should know it. Copper to copper 2+, and nitric acid going to NO2. Any questions? Okay, if you do those equations while I'm just packing the stuff up.